Hi, my name is Scott Pepper. Today we'll be learning about a new component that can be used in the HP C-Class enclosures, specifically the new HP ProCurve 6120 blade switch series. There are two models of these new blade switches, the 6120G-XG and the 6120XG. Unless otherwise specified, we'll use the term 6120 blade switch to refer to both of these models. These new blade switches are equivalent to taking a ProCurve external, stackable sized managed switch and fitting it into a blade footprint. When installed in a C-Class enclosure, the 6120 blade switch series allows the network administrator to easily deploy and provision network access to server and storage blades that are co-resident with the blade switch. This lab will begin with a brief overview of the 6120 feature set, followed by installation and configuration of the 6120 within a C3000 blade system enclosure. Once the 6120 is configured for basic operation, the lab will then progress with the configuration of a C3000 enclosure for operation with the 6120 switch. The lab will further demonstrate the interaction of the blade server virtual NIC with the 6120, including the assignment of an IP address on a single NIC and concluding with NIC teaming. Let's take a look at the front panel of the 6120 switch. You will notice many recognizable features on this switch, such as the standard link status and activity LEDs, a module status LED, a module UID LED, a mini USB console port for serial connection to the switch. However, other methods of switch access are available, such as the HP OA serial port and the traditional connection methods of web interface, telnet, and SSH, a switch reset button used to initiate a reboot of the switch, and a clear button used to clear the manager and operator privilege level passwords. Using the clear and reset buttons together causes the switch configuration to be reset to its factory defaults. The operation of these control buttons is configurable using the front panel security command available from the CLI. In addition, using the clear button alone allows you to remove any passwords and configuration settings, and using the reset button alone allows you to reboot the switch. The 6120G-XG blade switch has 9 external Ethernet ports. The external ports function as uplinks that can be used to connect to one or more upstream switches. The external Ethernet ports consist of the following: 1. 10 gigabit Ethernet CX4 port. 2. 10 gigabit Ethernet XFP ports. These 10 gigabit Ethernet ports support SR multimode fiber and LR single mode fiber XFP transceivers. 2. 1 gigabit Ethernet SFP ports. These 1 gigabit Ethernet ports support SX multimode fiber and LX single mode fiber SFP transceivers. And 4 10, 100, 1000 RJ45 ports. The 6120XG blade switch has 9 external 10 gigabit Ethernet ports. However, their composition is different from the 6120G-XG blade switch. The 6120XG contains one 10 gigabit Ethernet CX4 or one 10 gigabit Ethernet SFP+. The port labeled 17 is a shared port and can be used for either 10 gigabit Ethernet CX4 or 10 gigabit Ethernet SFP+ connectivity. Please note, the SFP+ port always has precedence over the CX4 port. 5 10 gigabit Ethernet SFP+ ports. These 5 ports are dedicated 10 gigabit Ethernet SFP+ ports. 2 10 gigabit Ethernet SFP+ ports. Individually, the 2 ports labeled 23 and 24 can be used as either external 10 gigabit Ethernet SFP+ ports or internal 10 gigabit Ethernet switch-to-switch crosslink ports. Please note, the external SFP+ ports 23 and 24 always have precedence over the internal switch-to-switch port. All the SFP+ ports on this switch support SR multimode fiber, LR single mode fiber, and LRM multimode fiber SFP+ transceivers. These ports also support a 10 gigabit base T mini GBIC that has an RJ45 light connector. Note that all 10 gigabit Ethernet SFP+ ports also support 1 gigabit Ethernet SFP transceivers. If we look at the rear of the switch, you will notice the connector which plugs the switch into the mid-plane of the C-Class enclosure. Internally, the switch has no fans or power supply. This is provided by the enclosure. Additionally, the 6120 blade switches have internal ports that function as downlinks to devices in the enclosure. The internal ports are essentially communication interfaces used to transfer data to and from server blades, storage blades, and even another 6120 if it is installed in an adjacent bay of the enclosure. The internal ports use the enclosure's mid-plane circuitry to communicate with the other C-class enclosure components. The internal ports of the 6120G-XG consist of 16 1 gigabit Ethernet device ports and one 10 gigabit Ethernet crosslink port. The internal ports of the 6120XG consist of 16 10 gigabit Ethernet internal ports and 1 to 2 10 gigabit Ethernet crosslink ports. Now that we have looked at the external features of the 6120 blade switch series, let's take a look at the installation of the switch into a C-class enclosure. The physical installation of a 6120 blade switch into a C-class enclosure is very straightforward. To install either blade switch, select an unused half-height interconnect bay located at the rear of the enclosure, remove the interconnect blank if present, insert the blade switch into the interconnect bay, and fasten the device bay shelf locking tab. We are now ready to begin configuring the 6120 for use with the C-class enclosure. In this lab, we will be using a 6120G-XG blade switch in a C3000 enclosure. After the blade switch has been physically installed in the enclosure, you can easily verify its status using the HP Onboard Administrator Management application, which we'll call OA. The OA is a web browser-based interface for configuring, managing, and monitoring a C3000 or C7000 blade system enclosure, along with the server, storage, and interconnect modules. Please note, for the purposes of this lab, it is assumed that the enclosure has been previously operational and that you are familiar with the basic features and functions of the OA application. This first screen provides overview information about the enclosure and includes graphics showing views of the front and back of the enclosure. Here you can see that we are logged in as a user with an administrative role. As you may know, this type of account is necessary to perform configuration changes within the OA. As we mouse over the left side tray of the enclosure's front view, we can see the status information of the OA management module. This information includes the IP address used to access the OA through the web interface. Notice that the firmware is at version 2.5.0. It is necessary that the firmware version be at 2.5.0 or newer in order to properly recognize the 6120 blade switch series in the enclosure. Lastly, the OA is indicated as active and its status is OK. Moving on to device bay 1, I can see that a HP ProLiant blade server named Server 03 is installed with an ILO address assigned to it. Here we see another ProLiant in device bay 2 with the name of Server 02. Moving over to the rear view of the enclosure, as I mouse over interconnect bay 1, you see that a 6120 blade switch is installed. Here it shows the status of OK. Notice there is no name or IP assigned yet. If we move our view to the Interconnect Bay Summary tab, we can check the status of the blade switch that has been installed in the enclosure. Notice the management URL is currently blank. This is the IP used for web browser access. The reason URL is blank is because the blade switch has not yet been assigned an IP address within the OA subnet. After an IP address has been assigned, this field will be updated with a hyperlink that can be used to launch the web browser interface of the blade switch. If we drill down into the switch information, you can view diagnostic information under the Status tab. If you were to click on the Information tab, you can expect to see that the management IP address is unknown, since it has not yet been assigned. The management IP address for the blade switch must be within the OA subnet. Although the blade switch shown in this example has not yet been assigned a management IP address, you would be able to access the blade switch CLI indirectly through the OA management module's DB9 console port or directly through the blade switch's USB console port. Next, let's take a look at the port mapping tab of the blade switch in Interconnect Bay 1. As was mentioned previously, the 6120G-XG has 16 internal 1 gigabit Ethernet ports that are accessed through the enclosure's midplane. These internal ports are used by the server and storage blades to communicate through the 6120G-XG when accessing the enterprise network. The external ports of the 6120G XG provide the connectivity to the enterprise network. Here we can see the two server blades that are currently installed in the enclosure. Based on the bay locations used, the server blades are automatically assigned particular internal ports. This assignment process is static and predetermined by the enclosure. Here, the two server blades are installed in bay 1 and bay 2 on the front of the enclosure. The server blade in bay 1 is assigned internal ports 1 and 9, whereas the server blade in bay 2 is assigned internal ports 2 and 10. Each server blade is automatically provided with network access for both the server blades, Ethernet NIC, and iSCSI Storage HBA, host bus adapter. Notice the 10 gigabit Ethernet internal switch-to-switch cross-link port that can be used to communicate with an adjacent blade switch of the same model, if installed, is not included in this port listing. We are now ready to configure the 6120 blade switch with an enclosure bay IP address, eBIPA or eBIPA for short. The IP address within the OA subnet that you assign to the blade switch is used by a switch component known as out-of-band management and is abbreviated as OOBM or UBM. Access to the blade switch through this IP address is considered out-of-band compared to any other VLAN IP addresses that may eventually be configured on the blade switch. These latter VLAN IP addresses can be thought of as being used for in-band purposes. For example, the IT group that manages all switches and routers in the enterprise network will typically assign each network device an IP address in a management VLAN, such as VLAN 1. To configure the UBM component, you click on Enclosure Bay IP Addressing and then click the Interconnect Bays tab. Notice that the shared interconnect settings are already populated. This is because they are system-wide settings and apply to all devices within the enclosure. The default gateway is typically an upstream router or switch. We now click the checkbox for Bay 1 where the switch is installed and then enter the IP address we wish to assign and click Apply. After clicking OK for the warning about DHCP lease expiration, the UBM address has now been assigned. Let's ensure the UBM address has been assigned by navigating back to the Interconnect Bay summary. Notice the management URL is now populated. We now navigate to the Interconnect Bay 1 Information tab and notice there is now a link for the Management Console as well as the management IP address listed under the Information tab. Let's now access the Management Console by clicking on the link. This will bring us to a web interface very similar to that of other HP ProCurve switches. Here you see a graphical overview of the status of the switch ports. This web interface can also be accessed by directly entering the UBM IP address as the URL in a web browser. At this point, it is assumed that only the OA management IP address has been configured. That is, no other VLANs with associated IP addresses have been configured on the blade switch. Therefore, the only IP address that is available for accessing the blade switch is the OA management IP address. After an IP address is configured for VLAN 1 or any other VLAN, you can also specify one of those IP addresses. Notice that D1, D2, D9, and D10 are all active because the servers are installed in bays 1 and 2. As a reminder, ports D1 through D16 correspond to the 16 internal 1 gigabit Ethernet ports. Ports 1 through 4 are the 10, 100, 1000 RJ45 ports. Ports S1 and S2 are the 1 gigabit Ethernet SFP ports. Ports X1 and X2 are the 10 gigabit Ethernet XFP ports. Port C1 is the CX4 port, and port I1 is the 10 gigabit Ethernet internal switch-to-switch cross-link port. This port is currently disabled because another switch of the same model has not been inserted into the enclosure. If we now move to the Configuration tab, we can see a graphical representation of the front of the blade switch along with a graphical representation of the logical internal ports, including the UBM interface. Now that we have configured the UBM interface, let's review how you connect to the switch through the CLI using the OA. Here I am using a terminal emulator named TerraTerm to telnet to the OA. Once I log in as a user with the administrator role, I can type help for a list of commands. Here I will ping the UBM interface of the blade switch I just configured to see if it's indeed reachable from the OA. If I want help with a specific command, I can type help and the command. For example, I need help remembering the command used to access the interconnect bay of the switch. It is also important to note the key sequence used to return to the OA's CLI. To do that, you type Control-Shift_. I will now press Enter to connect to the CLI of the 6120. The 6120 CLI is just like that of any other HP ProCurve switch. I press any key to continue, and then the command prompt appears. I can type help, or the question mark key, or the tab key for a list of commands such as configure, ping, show, and write. In addition, the 6120 supports tab completion. For example, I can enter the command show and then press the tab key to see the list of available show commands such as show configuration, show IP, show UBM, etc. Next, I will use the show version command to see what version of software the switch is running. I will follow up with the show flash command to see what version of code is installed in the primary and secondary flash locations, as well as what boot ROM version is used, and the flash location used as the default to boot the blade switch. Next, I will use the show IP command. Notice that there is no IP address configured on any VLAN defined on the switch. If we use the show VLANs command, you will see that there are no VLANs configured yet on the switch except for the default VLAN, VLAN1. Now, if we use the show UBM command with the tab key, you will see a couple of possible entries. Let's go through each. Show UBM will display the global configuration of the UBM interface, and yes, we see that it is active. Show UBM IP returns the IP address we gave it earlier. Show UBM ARP returns us with the MAC address of our default gateway, which is what the switch can currently see through the UBM interface. If we type show configuration, we can see the current configuration of the switch. We can see that the switch-to-switch interface, I1, is disabled. VLAN 1 is the default VLAN and is not currently configured with an IP address. Lastly, we also see that the UBM interface is configured to use DHCP for acquiring its IP address. In this scenario, the DHCP server resides on the OA management module. Next, we will configure several initial switch settings. During these steps, I will use tab completion for each keyword of the commands, so you can see each possible option. We begin by setting a hostname for the switch. The hostname is also used for the CLI prompt. Next, we configure the username and password for each of the manager and operator privilege levels. Then, we configure the SNMP settings. Notice that access to the SNMP community named public is unrestricted for the manager privilege level, but it is restricted for the operator privilege level. Next, we use the write memory command to save the changes made to the running configuration to the file stored on the flash. Then, we configure the IP address and subnet of the default VLAN, which is VLAN 1. Remember, this VLAN represents the management VLAN as opposed to the OA subnet. I will also configure the default gateway for VLAN 1, which in this lab is the upstream switch. There are many other initial configuration settings an IT group will likely apply, but are not shown here. The previous example settings should give you a sense for the typical configuration activities performed on a new switch. Let's take a look at our running configuration to see the changes we have made before moving on to the next major configuration task, which is to implement one or more uplinks between the blade switch and the external upstream switch. For this lab, the uplink will consist of 2 ports aggregated as a trunk using the industry standard Link Aggregation Control Protocol, LACP. Implementing a trunk with 2 or more links provides basic redundancy so that in the event one port or cable should fail, the other will continue to provide connectivity to the network. We are going to use 2 of the 10, 100, 1000 RJ45 ports. Port IDs 1 and 2 for the trunk connection to the uplink switch. Since this is the first trunk to be defined, we can use the trunk identifier TRK1 followed by the LACP keyword. Next, we will create a new VLAN named VLAN 2. The various blade servers in the enclosure will belong to this VLAN. Therefore, it will be given the descriptive name of web servers. Since the blade switch will be providing strictly Layer 2 switching service, an IP address does not need to be assigned to this new VLAN. We will now define the internal blade switch ports D1, D2, D9, and D10, which provide connectivity across the enclosure midplane to the servers as untagged members of VLAN 2. As a result, these ports are no longer untagged members of VLAN 1. This is because a given port can be untagged in one and only one VLAN. These ports are untagged because we assume that the servers do not need to send frames with a VLAN tag field. For example, if a server only services VLAN 2 traffic, then there is no need to differentiate traffic for transmission purposes. We will now assign the LACP trunk named TRK1 as a tagged member of VLAN 2. This allows the LACP trunk to carry untagged traffic for VLAN 1 and at the same time tag traffic for VLAN 2. As other VLANs are added to the switch to allow the corresponding traffic of the new VLANs to be transported over this trunk, the trunk will be added as a tagged member of each of those additional VLANs. It is important to note that the LACP trunk is configured in an equivalent manner on the upstream switch. We will now show the running configuration to view our updated configuration. Notice that ports D1, D2, D9, and D10 are all now untagged members of VLAN 2 and not VLAN 1. Notice as well that our aggregate trunk TRK1 is tagged in VLAN 2. We will now use the write memory command to save our configuration changes. Let's take a look at our active interfaces by using the show interfaces brief command. Here we can see the status of our internal ports D1, D2, D9, D10 is up, as it is for our external ports 1 and 2. We can prove this connection is active by being able to ping our upstream switch from the 6120 blade switch. Now that we have interconnectivity between the 6120 blade switch, the chassis OA, and the upstream ProCurve switch, we can begin connecting the blade servers to the network. We can begin at the chassis OA by going to the port mapping section of the server in device bay 1. Notice how this server is using internal ports 1 and 9 of interconnect bay 1. If we now log into the management console of the ProCurve 6120, which is in interconnect bay 1, you will notice on the graphical web interface that switch ports 1 and 9 are active, in addition to ports 2 and 10, which are being used by the server in device bay 2. Going back to the OA, we move to the ILO interface of the server in Device Bay 1 and click on the Integrated Remote Console Full Screen link. This will bring up a remote desktop session to the server in the Device Bay 1. Next, we log into the server and take a look at the network connections for the server. You can see that local area connections 5 and 6 are both connected. These are in effect virtual NICs. If we look at the properties of NIC 5, we can see that it is configured for DHCP. The same holds true for NIC 6. Next, we will examine the relationship between the 6120 Blade Switch's virtual ports and the servers in the Blade system enclosure. Here, you can see the active network connections for the server in Device Bay 1. If we go to the CLI of the 6120 Blade Switch and disable port 1, we can see the active connection for NIC 5 is now disabled. This is also evident by examining the graphical representation of the switch port. Next, let's re-enable port D1 and disable port D9. Notice NIC 5 is acquiring an address while NIC 6 is now offline. Again, this is represented by the graphical interface of the switch ports. Now, we will re-enable port D9 and then verify that the switch port is indeed active by looking at the graphical web interface as well as server NIC. Next, we will now assign a static IP address to local area connection 5 of the server in Device Bay 1. After assigning the static IP address, we can test the connectivity by pinging the IP address from a command prompt window. Notice that I have specified the -T option so that the ping command runs continuously. I will also test connectivity by pinging from the CLI of the 6120 Blade Switch. Next, let's proceed by teaming the virtual NICs of the server. This would be a typical configuration action to take so that the server has the advantage of using either NIC to communicate with the 6120 Blade Switch. First, we access the properties of NIC 5, which is currently the active NIC with an assigned IP address. We then access the properties of the HP Network Configuration utility. This will show the current virtual NICs of the server. We select NICs 5 and 6 and click the Team button. Then click OK. We then close the window and wait for the utility to configure the NIC team. The time for this process can vary from a few seconds to a couple of minutes. Once the team is created, you will notice a new virtual NIC connection with the description of HP Network Team 1. If we access the properties for this NIC connection, we will see that the IP address previously assigned to one of the virtual NICs has been removed. Therefore, we can assign the same IP address that was used previously. Now notice when we go back to the command prompt window where a continuous ping of this IP address is running, once the IP has been applied to the new NIC team, connectivity is restored and the server is back online. Now, if we return to the HP Network Configuration utility, you will notice that the NIC team shows a green icon to indicate it's active. If we select the NIC team and view the properties and then select the Information tab, we can view the current mode, speed duplex, team state, as well as the MAC and IP address assigned to the team. We will now go back to the 6120 CLI and configure an LACP trunk named TRK2 between the internal switch ports and the virtual interfaces of the newly configured team. Remember to untag this new LACP trunk in VLAN 2. Notice that the current mode of the team changes from transmit load balancing with fault tolerance to 802.3 AD dynamic with fault tolerance. Also, notice that both team members have assumed a full duplex transmit receive role, where team member 6 was previously operating as a transmit only role. This will conclude our video lab segment on the initial configuration and operation of the ProCurve 6120G XG blade switch. I hope you found it helpful. If you have further questions or would like to learn the more advanced switch configuration commands, please visit procurve.com. Here you will be able to download several switch configuration manuals detailing in depth all switch commands and configuration uses. Thank you for your time and have a wonderful day.